So here's an example that we didn't go over in class, so I thought I'd make a video of it. The CEO of a large electric company, utility company, claims that 80% of its customers are very satisfied with the service they receive. To test this claim, the local newspaper surveyed 100 customers using simple random sampling. Among the sampled customers, 73% said they were very satisfied. Based on these findings, can we reject the CEO's hypothesis that 80% of the customers are very satisfied? Use a 5% level of significance. So this is a test of proportions, hypothesis test. Let's label the given information. So 100 people were surveyed, and 73% of them were satisfied. That's p hat. P hat is the proportion of your sample with that characteristic. So if they had told us the number of people out of the 100, like 12 people or 17 people, that would have been x. P hat then would have been x over n. But they already gave us the percentage, so that is p hat. What else do we have? We have a 5% level of significance. And we can come up with the rough draft of our claims. The claim is that 80% are very satisfied, so that the population proportion is 80%. So the opposite statement mathematically would be not equal to, I should put this as the claim, sorry. We don't actually even have to change anything to formalize our hypotheses, since we already have a strict equality, the equal sign. Remember, whichever one has the equals or the equals in it somewhere becomes the null. The other statement becomes the alternative. Because we have not equals here, that makes this a two-tailed test. So that means we're going to have to find alpha over 2, since it is a two-tailed test. And we're going to be using the z-table because we don't have a sample standard deviation. Sample standard deviation means use the t-table. For everything else, you use the z-table. All right, that's steps 1 and 2. We've labeled all the given information, and we've formalized our hypotheses. The next is to verify the conditions are met. So that's normality. And what we need here is that n times p and n times q are greater than or equal to 5. And we're going to put the actual numbers in here. So if p is 0.8, q is then 1 minus 0.8. So q is 0.2. So n, 100, times p, 0.8, that's 80, which is greater than or equal to 5. N times q is 20, also greater than or equal to 5, so both of these are good. That was step 3, checking for normality. This allows us to draw the curve and find our critical regions. Two-tailed test. So we have two tails here. We will have two critical values, a positive one and a negative one. And in each tail, we have alpha over 2, 0.025. So we're going to look this up in the z-table and find the z that gives us an area of 0.025, and that will give me this negative critical value on the left. See, negative 1.96. So that means this upper value is positive 1.96. These are our two critical values. And so these tails are the critical regions. So now we need to find our test statistic. The formula here is z equals p hat minus p divided by the square root of pq over n. P hat is 0.73, p is 0.8, divided by the square root of 0.8 times 0.2. Remember, p and q, that's the information that's obtained from the null hypothesis, divided by n, which is 100. I'm getting negative 1.75, which would be about here. It does not fall in the critical region. It would need to be smaller than negative 1.96 to be in the critical region. It's not in the critical region, so the first start of our conclusion is do not reject the null. We then look at our conclusions. Our claim was in the null hypothesis, and we said do not reject the null. So our conclusion is there is not enough evidence to reject the claim that 80% of the customers are very satisfied. Do not reject the null. There is not enough evidence to reject the claim that 80% of the customers are very satisfied. And that is our final conclusion.